Hello friend. Hello friends. Today we are seeing new Bayes theorem in machine learning. In machine learning we are often interested in selecting the best hypothesis H given data capital D, small d. In a classification problem, our hypothesis H may be the class to assign a new data instance D. One of the easiest way of selecting the most probable hypothesis given in the data that we have that we can use as our prior knowledge about the problem. Bayes theorem provides a way that can be calculate the probability of hypothesis given our prior knowledge. Bayes theorem is stated as P of hypothesis upon instance data instance is equal to P of that is D upon H, that is hypothesis uh, data instance upon hypothesis into hypothesis probable hypothesis upon probable data instance, where P of hypothesis upon D is the probability of hypothesis H given the data H D. This called as a posterior probability. P of D upon H is the probability of data D given that the hypothesis H was true. P of H is the probability of hypothesis H being true regardless of the data. This is called as the prior probability of H. P of D is the probability of the data regardless of the hypothesis. You can see that we are interested in calculating the posterior probability of P of H upon D from the prior probability P of H with P of D and P of D upon H. After calculating the posterior probability for a number of different hypotheses, you can select the hypothesis with the highest probability. This is the maximum probable hypothesis and may formally be called the maximum a posteriori map hypothesis. This can be written as map, that is maximum priority posteriority of H is equal to max of P of H upon D. Map of H is equal to max of P of H D upon H star into P of H divided by P of D. Map of H is equal to max of P D of D upon H into P of H. The P of D is the normalizing term which allows us to calculate the probability. We can drop it when we are interested in the most probable hypothesis, as it is a constant and only used to normalize. Back to classification, if we have a given number of instances in each class is our training data, then the probability of each class, it is P of H, will be equal. Again, this would be a constant term in our equation. We could drop it, so we end up with map of H is equal to max of P upon D upon H. This is useful exercise because when regarding a further naive Bayes, you may say all of these forms of the theorem. Naive Bayes classifier is a classification algorithm for binary two-class and multi-class classification problem. The technique is easiest to understand when described using binary or categorical input. It is called naive Bayes or idiot Bayes because the calculation of the probabilities for each hypothesis are simplified to make their calculation tractable. Rather than attempting to calculate the values of each attribute value P of D1, D2, D3 upon H, they are assumed to be conditionally independent given the target value and calculated as P of D1 upon H star P2, P of D2 upon H and so on. This is very strong assumptions that is most unlikely is in real data, that is that the attribute do not interact. Nevertheless, the approach performs surprisingly well on the data where this assumption does not hold. Representation used by naive Bayes theorem models. The representation of naive models is probabilities. A list of probabilities are stored to file for a learned naive Bayes model. This includes class probabilities, conditional probabilities. Learn a naive Bayes model from data. Learning a naive Bayes model from your training data is fast. Training is fast because only the probability of each class and the probability of each class given different input x values need to be calculated. No coefficients need to be fitted by optimization procedure. Calculating class probability, the class probabilities are simply the frequency of instances that belong to each class divided by the total number of instances. For example, in a binary classification, probability of the instance belonging to class 1 would be calculated as P of class is equal to 1 equal to count of class 1 is equal to 1 divided by count of class is equal to 0 plus count of class is equal to 1. In the simplest case, each class would have the probability 0.5 or 50% for a binary classification problem with the same number of instances in each class. Calculating conditional probabilities, there will be the frequently of each attribute value for a given class value avoided by the frequency of instance with that class value. If weather is attribute and values sunny and rainy, and then the attribute has the class values go out, stay home, then the condition probability of each weather value for each class value could be calculated as P of weather equal to sunny, class is equal to go out is equal to count of instance with weather equal to sunny and class is equal to go out divided by count of instance with class go out. In this way you can summarize or you can write the probabilities for the or the instances, frequency of instances for the weather attribute. Now best prepare your data for Neo-Bayes. Categorical inputs. Neo-Bayes assumes labeled attributes such as binary, categorical or nominal. Gaussian input, if the input variables are real valued, a Gaussian distribution is assumed, in which case the algorithm will perform better if the univariate distributions of your data are Gaussian or near Gaussian. This may require removing outlier, that is example values that are more than 3 or 4 under standard deviation from the mean. Classification problems. Neo-Bayes is classification algorithm suitable for binary and multiplication classifications. And last one is the log probabilities. The calculation of the likelihood of different class values involve multiplying a lot of some numbers together. This can lead to an underflow of numerical precision. Such is good practice to use a log transform of the probabilities to avoid this underflow. Now next one is kernel function. Rather than assuming a Gaussian distribution for numerical input values, complex distribution can be used such as a variety of kernel destiny function. Update probability. When new data become available, you can simply update the probability of your model. This can be helpful if the data changes frequently. Hope so all of you are understanding what is the meaning of Neo-Bayes theorem and what's the equation and how it will be used. Thank you very much for seeing this video. Please like, share and subscribe.